Hey everyone. In this problem, we have a circular loop with some magnetic field going through it, and we're asked to find the strength of the magnetic field based on its flux. At least that's what part A is asking, which is what we're going to tackle first. Now the thing we need to know for this problem is that this is the formula for the magnetic flux, phi sub b, which states that the flux is going to be equal to B, the strength of the field, multiplied by the surface area of the loop, multiplied by the cosine of theta, or the angle between the direction of the magnetic field and the direction of the normal to the loop, the point that goes directly through the loop perpendicularly. So if we had a picture of our loop, then we could represent the direction of the normal by using a dot or by using an X symbol to indicate that it's either into the page or out of the page. For our purposes, however, the problem tells us that the field is directed perpendicular to the plane of the loop, which means that theta, the angle, is going to be 0 degrees. And if theta is 0, that means that the cosine of theta, because the cosine of 0 is equal to 1. So for our purposes, for part A of the problem, this is basically just the same as saying just B times A and nothing else. Now we're not told the area of the loop, but we are told that the loop is circular. Now recall that the area of a circle, so A sub C, is equal to pi multiplied by the square of the circle's radius. So we're going to use that here since we're given the radius of the loop. So instead of writing A, instead I'm going to write pi times r squared. And all of this is equal to the flux. Now we're given the flux, and B is what we're trying to find since we're asked to find the strength. So what I'm going to do to solve for B is algebraically solve for B by dividing both sides of the equation by pi r squared. So what we find is that B is equal to the flux, phi sub B, divided by pi r squared. So all we got to do is plug this into our calculator and also make sure that the units check out properly. So for phi sub B, that's given to us in the problem, is 8 times 10 to the power of negative 3 Tesla meters squared. And then we divide the whole thing by pi times, and then the square of r, which is given to us in the problem as 12 centimeters, which we'll have to convert to meters. So that's 0.12 meters. And that whole thing is squared. And if we put that into a calculator, then we find a value for the field strength of approximately 0.177 Teslas. And that is the field strength, and therefore the answer for part A. Now let's look at part B. Let me try writing that in a neat way. Part B, which is the same idea, except now we're told that the magnetic field is directed parallel to the plane of the loop. So going back to our diagram, this would be like if we had a circular loop here, and the magnetic field was directed, instead of being into or out of the page, instead it's going through the plane like this. So what's happening in this case is now there is a 90-degree angle between the direction of the field and the normal to the loop, which means that instead of using the cosine of 0 degrees, instead we're using the cosine of 90 degrees, which is equal to 0. And also, instead of being asked to find the magnetic field, instead this part of the problem just asks for the magnetic flux. So let's pull up the formula we had before. The magnetic flux, phi sub B, is equal to B times A times the cosine of the angle. Except we just established that for our purposes in this part of the problem, that cosine of theta is just going to be 0, which means that the whole term goes to 0, and there is therefore 0 flux through the loop in this part of the problem. Which makes sense when you think about it, because if you look at the diagram, if you look at the way the field lines are going parallel to the loop itself, that means that none of the field is actually going to be penetrating through the loop. So it makes sense intuitively to think that there is going to be no flux in the loop. And that is it for both parts of the problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this one. If you have a question, leave a comment down below, and I'll do my best to clear anything up. If you have a request for a future video, or you would just like to hang out, my Discord server and my Twitch page are both linked in the description below, so check those out if you'd like. But that's all for now, and I hope you all have a lovely day. Bye-bye.